Alright, we're going to do an example where we're modeling an object in flight with parametric equations. Parametric equations is a great way to model things in flight because you can include a new parameter, which is time. It allows you to play with time and see the distance and the height of the object as time either continues or goes backwards. It's a great way to model flying objects. Okay? You got to remember how to write these equations. Okay? So what we got here is a golf ball on the ground, and it's being hit at an angle of 12 degrees with a velocity of 230 feet per second. Okay, so it flies over here. And there's a green that is 220 yards away, and it has a radius of 10. So this distance is 20 feet. I've got to see if the golf ball is going to land on that green. Okay. First of all, if everything's in feet, let's change this to feet. 220 yards is 660 feet. Okay. We first have to know how to write the parametric equations. X, we're going to use the horizontal component of this velocity. When we're doing the horizontal component, we're always using cosine. So it's going to be the magnitude times cosine of the angle, and that times our parameter t. And when we're in feet per second, the y equation starts with negative 16t squared. That's the acceleration constant. And now with the y equation, we're going to use the vertical part of this velocity, and we always use sine. Okay? So we're going to go 230 sine of 12 times t, and it's resting on the ground, so our initial height is 0. Okay, so once we have that, we can just graph it. We need to be in parametric mode and in degree mode, because we're dealing with degrees here. Okay, so, So parametric and degree mode, go to my y equals screen. Okay, so 230 cosine of 12 times t, and then negative 16 t squared plus, let's see, 230 sine 12 t, and that's it. So a window, let's see here. 0, it's not going to take very long to hit the ground. I'm going to go 0 to 6. I like 0.1 as a t-step. X min, X max. X max, it's going to travel a ways, 660 feet. Let's hope that 700 is a big enough window. I'll go up by hundreds. And this is a pretty low angle, so I don't think it gets very high. So my y min I'll make 0. My y max, 80 is probably pretty good. I think that's plenty actually. And maybe my y scale is 10. Okay? Graph should get a nice arc. Oh, it's not. I put 23 instead of 230. There we go. We get a nice arc. So what happened there was, oh, it's in dot mode. There we go. There's a nice arc. So if I trace all the way over, so that this y coordinate is close to 0. That's pretty close. So the idea here is that it needs to land between 660 feet and 680 feet for this golf ball to land on the green. So if I look at my graph, sure enough, when y is close to 0, it's traveled 674 feet. So it's going to land actually closer to the back side at 674 feet. But definitely closer than 680 feet, so this will land on the green. So yes, the golf ball will hit the green. Alright, very good.